the entire drawing here is done off one sketch. I know I got a number of sketches there, but I'm going to do it off one to show you how one sketch can be versatile. And I'm going to look at the threading and the fancy bits on the nuts and the knurling. So we'll go to a fresh sheet, and the first thing is to go into sketch. And what I'm going to do here is, as usual, I'm not that fussy on dimensions. I'm going to use dimensions which are there for a 10 millimeter threaded bolt, but it's not about dimensions, it's about what I'm doing. So the first thing I want to do is to do the head of the bolt. So I'm doing a inscribed hexagonal there, and I want to make it 24 across the flats. Now to get 24, then it's 12 because it's the radius of it. So there's our starting point, as it were. Next thing, I want to put a circle in the middle, which is going to that point there. And then I'm going to put a circle in there, which is going to be 10 millimeters in diameter, which is the thread. That's the sketch I'm going to use, and from that sketch we're going to make all of that, okay? So the first thing is what I would call is to start the head of the bolt, which is perhaps the easy part. So let's finish the sketch. And what I do is highlight the lot and go into extrude, and I want a head that's 10 millimeters thick. I'm going to do 5 millimeters on this, and that will become apparent as we go through the drawing, okay? And I'm going to do -5 because I want to keep the sketch on the top. If I just drag it up there, the sketch goes on the bottom of the drawing, which is not what I want. So we'll do -5 and enter. So there's my start of my bolt head. Now the next stage is to look at getting these chamfers on, which is very straightforward, because what we're doing with that one is we pick both circles and then we go into extrude, and we go extrude down there, and that cuts. But if we go over to our box and change our taper angle to 45, and we don't do a cut, but we do an intersect, there's our head done. Now I'll just go back one to show you what happens if I don't select both circles. If I just selected the outer circle and done exactly the same thing, taper angle 45, distance -5, oops, hang on, taper angle, there will be 45, distance 5, -5, sorry, -5, and go to intersect again. You can see I get that middle bit as well, which might be useful for you. So let's go back to where we were. Finish sketch, and as I say, highlight it all. I'm going -5, which will become apparent in a moment. I want 45 degrees. I want to intersect. What have I done wrong? Hang on a minute. Wrong way round. I didn't do the body first, did I? -5. There's the body. Right. Both circles. And we're going to -5, or we can just click the bottom base, as you know, which will get us there. 45 degree angle again. 45. Intersect. And there's our top of our nut. Now you'll see why it's 5 millimeters in a moment. So the next thing I want to do now is to produce the actual nut itself. So I'm going on, and this time I'm going to highlight all of that, hit the copy command, make sure I'm on bodies, select the body, and then I'm going to do a copy of the body, and I'm going to bring it down. It really doesn't matter how far you bring it down, but bring it down, you know, 20 odd millimeters or so, so you've got working room. Okay, so to produce the nut now, we got the body over here, we select it, we go onto mirror, that's the body selected, then the mirror plane is the underside, that gives us our nut, and now you can see why I left this one at 5 millimeters, so I could produce the nut. Now we click on that one, we do an extrude, and we drop that down 5 millimeters, so we've got our 10 millimeter bolt head and our nut. Next thing now is to create the blank for this thumb wheel, as I'm calling it. So again, that is from that circle there and the inner circle. And the same technique, we're doing that one, and I want it 10 millimeters. But I want it down here somewhere I can work. So again, we're going to do offset, and we're going to do an offset of maybe 50 might be enough for us, is it? Wrong way, minus 50. What might no? Getting confusing now, that one there. Offset minus 50, sorry. So there's my 3 starting points. Next one is to put the shaft through. Now, if I just click on that and extend it, I don't want it cut, obviously. I can either join it or have a new body. I don't want a new body because I want it joined to the head. But if I click on join and do OK, I get one body, because the join command joins it to the head, which I want, but also will join it to the nut and the thumb wheel, which it goes through. So let's just backtrack a moment. And what I'm going to do this time is switch off the 2 bodies with the highlight over here, then click on that, then bring the bolt length down and do a join. Switch them back on. So now you can see I've got the 2 there and I've got my bolt in one. Okay? Next stage is to put some threads on. So let's hide this body one out of the way for the moment. But we've got no holes in. So what we're going to do is we're going to take that one there, bring it down to there and cut. And that gives us our holes, and the original bolt is still in place. Putting the threads on is quite easy. I already set this hole to 10 millimeters. So it's create and thread and click on the wall you want to put it on. Now, one thing you need to click on if you want to see it is the modelled tab up here. Otherwise you won't see it. So click on modelled, and there I want it to stick at 10. Now you've got some options here, and this is the pitch. If you're printing on filament printer probably, then I would advise you go for the biggest pitch you can so that you've got a chance of printing it. The quality of print obviously will depend very much on your printer, and when you're doing threads like this and you want to keep things like layer height to a minimum. Click OK, there's our thread in there. Okay, same on this one, click on the inside up to here, thread, and again make sure it's modelled, and there you go. Now before we go any further, let's just put a bit of colour on before we start losing ourselves. So we can go into appearances. I'll change that one to a red. Don't worry that it's done all of them, that doesn't matter. I want that one there, and we will have that as a grey, and then drag that out and put it on that body, and then onto that body. And there we can see some differentiation which might help us. Okay, now then, as I said, you've got the threads on the nut and the thumb wheel. What we need now is the thread on the shank, as it were. So again, delete the 2 bodies we don't want so we can see what we're doing. Highlight that and create and thread. and model it. Now, you might not want the thread going all the way up, in which case you can click on full length, and then you've got two arrows. You've got this arrow, which adjusts that one, and you've got that arrow that adjusts the top one. So what we'll do, we'll have a little bit of non-thread at the top and bring that one down to the bottom. And again, you've got the option to change it here. Obviously, you want to keep it the same as the threads you put in the other two, otherwise it's not going to screw together. And click on it. So there's our 3 bits. They're finished now, as it were. I'll come on to the red one in a moment, just so you know, because what we want to do with the red one now is put a knurl on it. And knurling is where sometimes gets a bit complicated, I don't know. So let's switch off the ones we don't want, and we're on this one. Now what I'm going to do, which will become clear why, I'm first of all going to put an offset plane, construct offset plane from that base, 1 millimeter. We don't want much. And that will become apparent why I want that in a moment. Now create, and we're going down to coil, and we're putting the coil on that plane, and we'll go, and what we're doing now is we're going to put the center of the coil, which is there, and we want the outside of it just only, 0.2, 0.3 millimeters beyond the edge of the thumb wheel, and you'll see why in a moment. And it started to create the coil. Oh, let's get so you can see it. Now that's designed that the coil will do that sort of path around it. Now what we want revolutions. You can't have 1 revolution, so 0.1 will do us. Then tick that arrow and pull it up so that this edge here is above there. You can see now why I went below there to make a good start. Now if we go over there, we can see that's way too deep for what we want. So in here now we can come down and we can change this cut, and let's say 0.75, and you can see the cut is different. You've got several types of cut. I'll zoom in so you can see it a bit better there. You can have a circle one, you can see the circle effect there. You can have a square one. You can have a triangle external, which is that way where the base is inside and it's coming out. But one we want, or the one I want to decide on for this, is the internal one there, which you can see creates a V. So that's nice. So I can click OK on that one now, and I've got 1 mark on there. Now knurling, you can see the shape there. So you can see we've got the 1 line in. So back to the one we're working on, and what we need to do now is get a line going the other way. So the easiest way of doing this is to go into the mirror command, select, leave it on features, select that feature, and then the mirror plane, it really doesn't matter, but it's that one there. You want to get it somewhere across the other side. So click on that one, OK, and we now got one there, and we've got one on that side as well. Next job is create, pattern, circular pattern, features, objects. So we select, you might have to zoom in this to actually get it, otherwise you'll be selecting everything. Select that one. You don't have to hold the shift key down when you're selecting multiple ones here, and select that one. And the axis, which will be the blue axis, which goes down the middle. And 40 is the number of repeat patterns. 40 looks good for this. You might want less, you might want more, it depends what you're doing. You could do the same effect if you wanted straight lines. You would just put a straight line on there, indented, and then copy that round. But I don't know about you, I was brought up in engineering, and many years ago, over 60 probably, the one thing I used to enjoy on the lathe was doing knurling. It always gave you a degree of satisfaction when it came out and looked good. Click the OK button, and then you have to wait a moment while it computes. Depends on what sort of speed you've got on your computer. And there we have the knurled one as well. So switching them back on again. There we have our 3 parts that we want. Now, we come to print them. Okay, we could combine them. But we don't want to combine them because you don't want to print that in one go. You want to print it in 3 different goes maybe. So what you can do, of course, you can go to utilities, you can go up there, which will bring that up. You can select the part you want, say that one, and you can press OK, and off it goes to your slicer, and it's on the bed. Lovely. And then you can't get the other 2 because they'll open up new instances of your slicer. You could copy it from the slicer, STL, import, etc., as I think we've talked about before. But an easier way of doing it is basically to go on the body, right click on the body, save as mesh. Save that as, say, bolt, and tell it where you want to save it. Right click on that one, save as mesh. Right click on that one, save as mesh. Then open your slicer program and import the 3 STLs, rearrange them on your plate, set your settings, and print it. Now, one other side thing which I'll just show you, because this one, if we look at this, let's just pull this round. The steepness of these angles, you might have difficulty printing that sort of overhang. And of course, you really can't print this with blimmin' supports everywhere. Goodness knows what it would be like. There is a way round it, and I'll show you that way round and explain what needs to be done. So let me just put up a new one a moment, and this will be quite a rough thing really, just to show you what's happening. And we'll apply a thread to that, and we'll model it. So there you can see the overhang, because if we go into the thread settings, the only choices you've got are the standard choices here. You can't actually type anything in here, you just select what they give you. Now what we want to do, and of course even if you selected a larger pitch, you might still have the angle. But what we want to do, because it doesn't matter, we're designing this maybe for something on our railway in some shape or form, we can decrease these angles. And the way to do that is to go into modify, go into scale, select the object, and only scale that way. Obviously that's going to be ridiculous, but you can scale down there so you get an angle which is better. Now of course, if you put a scale say of 1.5 on it, you need to remember that your initial cylinder has to be that much less than what you want finished, because obviously you make it 1.5 longer when you do this technique. And the same would apply to the nut and the thumb wheel as well. So anything that you want to do this technique on a thread with, then have a play about first and say, yes, I need to put a scaling factor of 1.5 on it. So therefore, design the parts that much lower so that when they are expanded to 1.5, they are the size you want with the thread you want. Hopefully that's clear. If not, we'll have some questions in a moment when you can ask me. That's another one I did, because the other side of the coin now is, how do we alter that? And that's fairly easy. If we go back to our drawing again, and suppose I want to make this thumb wheel bigger diameter. So what I can do is this, I can take my timeline back to before I done the coil, which is there, okay? The construction plane is there, but there's no thing on it. Now, I want to make that bigger. Now, because that is generated from this sketch circle up here, if I go in and alter that sketch circle, it will alter these faces because they're based on the same circle. So what I can do now is go back into solid, and this time you can't use the extrude command because that's only available on a flat surface. But you can use the push-pull command, and you can come down on there and choose it, and then you can push-pull. But they're linked together, so that's not a good way of doing it either. So let me just go back to where we were. And hang on a minute, I'm getting lost now. So what we're going to do now is I'm going to go onto that plane there. Take that plane away. I'm going to do a sketch on there. And I'm going to make a larger circle on there. Let's say I want it that size. Finish the sketch. Extrude that up onto there. And that's done it. Now if I then bring that back over to here, you can't see the coil because it's in the middle when it recalculates. Let's give it a moment or two. It starts to get a bit slow at this stage, but it does get there eventually, I hope. Probably pushed my luck on the sides of this. Now you can see the coil is still there in the middle. Or not the coil, the knurling. I want it on the outside. So go back to this one, edit the feature. Drag that out to just beyond there. Click OK. It will then go into its compute mode again. And I have the knurling on the outside again. It works the other way as well if you wanted to make it smaller. So you can resize the diameter in any way you want, and then, as I say, you go back into that command, edit it, and basically you're altering the circle, which is the base circle for your coil, because this is just part of a coil. I've gone back into compute again. You can do the same thing, which is a bit easier with the hex nut as well, is that you can go back into the basic sketch and resize these as well. At that stage I'll stop,